Welcome to Drupal Haydn. My name is Bill Bohling. I'll be your host today. My ID on DrupalCon or Drupal.org is Sunset Bill. I'm going to be talking about Symfony today, but I'll start off by saying I'm not a Symfony developer. I do Drupal at Turner. I first heard about Symfony and Drupal when Dries announced it at DrupalCon in Denver, but I only really got curious about how they work together after a session at this year's DrupalCon given by Ryan Weaver, who's the docs lead for Symfony. The group I work with, we get together weekly for our own version of what we call TED Talks, and I decided that that would be a good opportunity for me to learn some Symfony stuff. So I'd come in on talk day, pick a Symfony component that I knew nothing about, look at the documentation and put together whatever kind of a talk I could come up with in 2 or 3 hours. I called these Surprise Symfony because I'd have no idea what I was going to talk about that day, and then I'd never tell anybody what I was going to talk about even when I did know. People seem to like them, so I've polished them up a bit and put them together into what you're going to hear today. I will warn you, this is going to be pretty dense. I'm going to go over a lot of stuff. Pretty much every component I'm going to be talking about today is worthy of its own presentation, but I'm just trying to show some of what's under the covers here, give you an idea of what's there, not so much how to do stuff, but just the idea that you can do stuff. And don't panic, I'll be making these slides available. There are a lot of code snippets. So you'll have the slides available up on the Drupal camp site soon after this presentation. So anyway, what is Drupal Haydn? It's a pun. Allow me to introduce Joseph Haydn. He was a mentor of Mozart and one of Beethoven's teachers. Perhaps that's why he's called the father of the symphony. His symphony number 94 is called Surprise Symphony, but I'll let you Google that one on your own. And so much for classical music. This is Fabien Potencier. He is the father of Symfony. He started the Symfony project in 2004 as a way to make web development easier and faster. And in 2005, he released Symfony under the MIT license. So what is Symfony anyway? The website says that Symfony is a set of PHP components, a web application framework, a philosophy, and a community all working together in harmony. Or as Ryan Weaver put it in his talk, Symfony is the reason we had to wait 3 years for Drupal 8. And who do we have to thank for that? These folks. This group met in February 2012, got together to discuss the web services and context core initiative for Drupal 8. They realized this was going to involve 3 major areas: web services, layouts, and turning the underlying tool set into a more loosely coupled framework. That's a lot. So rather than address all of these, they decided that a good RESTful architecture would make all the other things possible, and the initiative was scaled back to address just web services. One of the attendees at this conference was Fabien Potencier. You might recognize him in the green sweater, or the gray sweater there in the middle. And he pointed out that several of Symfony 2's components were already doing exactly what Drupal needed to do for this architecture. So rather than trying to emulate that in Drupal, they decided to just incorporate Symfony into Drupal 8. The last I looked, Symfony provides around 40-some components. Drupal uses about 20 of these. I'm not about to try to get into all of them. That would just be way too many. I'm just going to make you aware they're there so you can take advantage of them. And then I'm going to go into detail about a few of the core components and components that the group I work with has found useful in our work. So first of all, where is Symfony? After you've installed the Drupal site and run composer install, you'll find all of Symfony's components in this directory here, vendor/Symfony. It's all just sitting there waiting for you to use them. So let's get on to that. The first one I'm going to talk about is HttpFoundation. This is one of the major reasons why Symfony has been included in Drupal 8. It handles all of basically everything we need to do for request and response in a web transaction. It provides request and response classes and methods for dealing with those. And these do their job so well that Drupal uses them exactly as they are. It doesn't wrap them in anything. So what is a request? A request object basically contains all of the familiar PHP request globals wrapped up into an object, along with an attributes array that you can use to add your own stuff to a request and pass it along. And in addition to a request object, HttpFoundation makes each one of these as an object in its own right. So how do you get a request? One way is to get Symfony's create request from globals method, and this actually is how Drupal gets the request into Drupal. We'll look at that again a little bit. If you like to type more, or if you're manually creating a request, you can start one just using the request constructor and passing those PHP globals to that. Drupal, of course, does this for us in this method called HttpRequest. Now you can do that, but there are reasons why you might not want to. Does anybody here have any idea why not? Okay, I was really surprised when I learned this one too. It's pretty cool. But the big reason that this is that this only works for HTTP requests. That means it's not going to work if you're writing unit tests. It's not going to work for all queue processors. And it's not reliable for command line invocations. How that affects Drush, I don't know. I haven't tried it with Drush, so I can't speak to that. But a real big reason for not wanting to use the request object is that the request instance can change during the course of processing. So like we see here, it's possible to create a sub-request in code. If someone does this and then you later on call Drupal's request method after that, you really don't know what request object you're going to get. It might be the current request, it might be a parent request, it might be the master request, but you really don't have any control over that. So Drupal's request docs, they say that it's better to get a request from a service than to use that method. And what do you know? Drupal provides a service for that. It's called Request Stack. So if you get the request stack service and call get current request on that, that will get you the current request that you want to work on. And so this is really the best way if you need to get a request object. This is the way you want to do it. Request stack service, there's a Symfony component in HttpFoundation called Request Stack. And what it does is controls the life cycle of a request. So this means as long as you're calling get current request, you're always going to get the current request. If you want to get a master request or the parent request, there are get master request and get parent request methods for that also. I haven't gone into how those work or why you would use them, so that's more for you to read. Once you have the request, you can start calling methods on it. The Symfony request class provides a whole lot of methods. I'm not about to try to get into these either. The request class docs on Drupal.org will list all of those for you. Some of them are things like get content, get path info, get host info, a lot of the usual suspects that you might be doing as part of your processing. And in addition, the request object and the property objects are instances or subclasses of the parameter bag class, which means that you get all of these methods that you can use on any of those also. You can simulate a request by using request create like we see here. And you can also duplicate a request with the duplicate method. So looking at these, you can see some other reasons why you might want to use that request stack method also. Now that we've dealt with the incoming, we'll take a look at what goes back. For this, Symfony provides the HttpFoundation response class. This constitutes what Symfony will recognize as a valid response. And this is important because Symfony, in a Symfony transaction, it expects a valid Symfony response. So this one is pretty important. You can create a new response, add attributes to it, add content to it, however you want, and then to pass it on. In most cases, we let Drupal handle this. We just pass return arrays, let Drupal take care of the rendering and putting them in where they belong. But there are a lot of instances also where you don't want a nice rendered response. You might want to just return an XML feed, JSON API response or something like that. And so you can build that in this response as we see here. Symfony provides a couple others for us that make life easier. The first one is a JSON response. What this one does is you just get a JSON response object like we see here, and it'll handle all the details like encoding your data and also adding the content type header for you, so that makes your job a lot easier. If you're working with media or really large data transfers, there's a streamed response, as you see here. And in this case, instead of assigning content to the response, you just give it a callback that's going to handle streaming your data. If you need a redirect, there's a redirect response. Real easy to use. Drupal 8 is really big on caching, and so the happy news here is that response also provides a set cache method, so you can set caching attributes on your response. Once you've created your response, you call prepare on it. This just ensures that it is a valid Symfony response, and if it checks out OK, you go ahead and send it along. In addition to the responses we saw earlier that Symfony provides for us, Drupal extends or provides 4 of its own. The cacheable response exposes cache metadata, so this one lets you set caching on the render array level. The enforced response lets you deal with enforced response exceptions that are thrown by the form builder. HTML response gives you a cacheable response and adds Drupal attached metadata like libraries, settings, HTTP header, and HTML head. And lastly, there's the AJAX response, which extends JSON response and lets you add a callback to your response. Along with those, HttpFoundation provides all of these classes also. Again, another document reading exercise for the class. And that's going to be it for HttpFoundation. We'll move on next to the EventDispatcher component. This is one that really changes things for the way we work in Drupal. Before I go on with this, how many here are coming to Drupal 8 from Drupal 7? Okay. And how many starting out just with Drupal 8? Okay. For those of you who haven't worked with Drupal before, sorry for the rest of you. Up until Drupal 7, we were stuck with the hook system. What Drupal did there basically was expose various core methods along the way that modules could implement themselves. Drupal would go, hum along until it hit one of these methods, check to see what other modules were implementing them, call the module implementations, and then keep going. So a big part of implementing a module then, and a big pain of implementing a module then, was figuring out what hooks to use at the right time. There were like some alter hooks that were really obvious that you could hook into, but sometimes you'd want to get early on in the process, sometimes late, but you were pretty much stuck with whenever Drupal would expose a hook that you could tap into. And then you would also, if you had a module that you developed, you had to keep up every time Drupal released a new version. You would have to check the hooks, make sure that your module was using the right ones, because hooks would be deprecated, added, modified. It was kind of a pain. Drupal 8 still has hooks, but it also gives us the EventDispatcher. This one gives us a lot more flexibility in our processing. The way the EventDispatcher works is that code can dispatch an event at any time. Other code listens for events and responds when an event that it knows about occurs. So the dispatcher will dispatch an event and then see if anybody responds to that. If it gets a response back, it processes that and then moves along. So what this means is instead of having to rely on hooks and wait for a hook to come up, we can fire events anytime we want to in the process, respond to them anytime, and that really makes things a lot more flexible. Symfony defines 8 events. The request event happens at the very beginning of request dispatching. This lets you modify the request, or you can create a request at that time and return it before any other code gets executed. The exception event happens when an uncaught exception is thrown, so you can create a response or modify the exception. The view event happens when the return value of a controller isn't the valid Symfony response object that we've mentioned, and this lets you modify that and return a valid response if you want. The controller event happens when a controller has been found that handles the current request, and this lets you specify a different controller for the request. Likewise, the controller arguments, once the controller has been determined, gives you a chance to modify the controller arguments that get passed along. The response event happens when a response has been created, and this gives you an opportunity to modify or replace the response. The terminator event happens after the response has been returned, and this is kind of a handy one if you've got jobs that have a lot of overhead with them. You can return your response so the user gets a quick response and then handle all of your expensive stuff inside of this one. Lastly, the finish request occurs when a response has been generated, and this one's useful for resetting the application state if that's changed during the request. In addition to these, it's really easy to create your own events. It's a there are 3 steps to this. The first one, you create a class that defines your events that you're going to be handling or dispatching. All these are is PHP constants. That's all that needs to go in this class. Then, since you're going to have events, you need something to dispatch them with. So you're going to create a class that uses the EventDispatcher service. This class implements the dispatch method, which takes whatever data you want to pass along to your listeners. It instantiates an event on it, then calls Symfony EventDispatcher's dispatch method on the resulting event and listens for responses. If it gets a response, it does something with it. You could log it, return the response. You could dispatch another event with what gets returned from that, on and on and on. The third part of this is you need something that will respond to events. So you create a subscriber class. This extends the event subscriber interface, and to satisfy that interface, you implement this getSubscribedEvents method. And what that does is it says what event you want to respond to, or events. You can handle as many as you want. And then you specify a callback for the events that you receive. So this one here, I'm listening for a notification event. If I get a notification event, I call log notification to log that. So you set this class up, tell it what your subscribed events are, define your callback, and you're done. So how cool are these? I've got corn here to get you thinking about kernels. And we now look at Drupal's index.php, where all requests start and end. So we see the first thing here, Drupal instantiates a kernel object, then gets a request object from Symfony, and passes that request object to a method called kernel handle. Now, this is Drupal's kernel handle. Drupal's kernel handle, in turn, calls Symfony's HTTP kernel handle method, which wraps another method, and that method sends off events. The first one, it sends off a request event, checks to see if it gets a response, and returns that. If we get that, we're done, and on to the next request. If the request event doesn't get a response, it then dispatches the controller and controller argument events. It listens for a response for those. If it doesn't get a response from that, it then calls the view event. And if you don't get a valid response out of the view event, then you'll get one of a couple errors that either are or will become pretty familiar to you as you start developing controllers. But that's it for that's under the hood stuff. I'm now going to talk about a few of the more fun things. The first one I'm going to talk about is the Symfony DomCrawler component. This one basically lets you navigate and manipulate a DOM the way jQuery does with JavaScript. So this one's really useful if you're doing any scraping or data mining from other sites. For instance, my boss used this one to write a module that gets a list of sessions from DrupalCon sites so that we as a group can plan out which ones we're going to go to and get good coverage. To use this one, you just include the DomCrawler crawler class in your code. You can instantiate a crawler either with content, or if you want to create a blank object, you can just start a new crawler with nothing in it. Crawler lets you add content to your document, so you can actually build an entire document inside of crawler if you want. If you're using the Symfony Browser Kit class and make a client request, the response that you get back to that is already going to be a crawler object. So once you've got your crawler, then you can start filtering on it by HTML tags, and then you can get things by relationship or position. And if you've got the CSS selector component installed, which Drupal does, you can use jQuery style selectors here. So you can use your crawler, you can get node content, you can get node attributes. Notice here that in addition to the filter method that we saw in the previous slide, crawler also gives you filter XPath, so you can use XPath queries. The third example here, this underscore text, is kind of interesting. It's a special attribute that represents the value of the node that you're looking at in there. A couple other examples. Looking at some XML code here, we've got this. We want to be able to get the aspect ratio here out of this XML. There are a couple ways you can do that. The first one, you can register the namespace of your XML document and then use filter XPath to use XPath queries on that. If you don't want to, you don't have to instantiate or get the document. You can just use filter XPath and filter, as you see here, and get your results. Symfony provides different methods to add content. You can add specific HTML or XML content. There's the generic add content, or just add. All of these are doing the same thing, really. You can also crawl forms, and if you're crawling a form, a really interesting one here is this select button method. If you're crawling a form and you call this, the object that you're going to get back from this is the form that contains the button. And then once you have the form, you can get values on it, you can set values on it. The getURI method that we see here is pretty interesting for a form that calls a get. In that case, you're going to get the action and the query string back for the form from that call. And moving along, one of the big jobs in web development these days is converting data from one format to another. That's something we do. We definitely do a lot of this in the group I work with. But say you get in some XML and you need to do something with that XML, or nowadays we have a lot more headless stuff, in which case you need to get data from Drupal and deliver it via an API to a JavaScript front end. And for that, the serializer component is a really wonderful thing. It lets you serialize an object into a format or deserialize a format into an object. The way this works, it goes in two stages. So there's a normalize that will take an object and turn it into an array, and then an encoder will take that array and turn it into a format. Likewise, deserializing, a decoder will take the format and turn it into an array, and then the denormalizer will turn that array into an object. So to use the serializer, you set up a serializer and specify which encoders and normalizers you want to use. So in this case, I've got a JSON encoder. I'm just using Symfony's object normalizer. This one is suitable for most things you're going to do, though we'll see later that you can develop one of your own of these if you want. Once you've got your serializer instantiated and have an object you want to convert, you pass the object to the serialize method and tell it what format you want to turn it into. And so in this case, I've got a person object, and I'm going to encode it into JSON. So here a little more in-depth on that. We've got a persons class. We want to be able to send this to a React front end. So we're going to develop an API class. This API class is going to declare the encoders and decoders we want to use, set up our serializer object for us, and then take care of stuff. So in this one, we want to use a JSON. So we get the JSON encoder. We then tell the serializer to encode the person object using the JSON encoder and to return that. Now you'll recall that HttpFoundation has a JSON response. And actually, I would probably try using that first, it's a lot easier, and it might just work, but if it doesn't, then we can get fancier like this. We can actually be a little simpler if we're just doing JSON. Symfony has a JSON encode class, and you can just use that like here. So you just get the encode class. You don't have to worry about an encoder or a normalizer, and let this go, and you're off to the races. Okay, going the other way, say we're calling a REST service that gives us a list of persons in XML format. We want to be able to convert these into person objects that we can store in our Drupal database. So in this case, we're going to use deserialize. Notice we have an XML encoder. That's kind of I think that's kind of a misleading name, because an encoder can actually encode or decode, but we just call it encoder by convention, I suppose. But an encoder can have a deserialize method. If you've got that, then what you do is give it the incoming data, the class you want to deserialize to, and then the encoder to use. So in this case, we've got this data as an XML string representing a person. We've already defined a person class, and we want to use the XML encoder to convert that data into that person class. Serializer, you can also use this to update an existing object with an additional parameter to deserialize. So in this case, we've got this person named Bar who's 99 years old. They contact our customer service department and say, hey, wait a minute, my name is Fu and I'm actually only 69. So they enter that data. It comes to us in this XML for this person. We run serializer, telling it to populate this person object that we've got up here. That's the person that we see, let's see, yeah, down here. And when we're all done, Bar is now named Fu and they're 30 years younger. Symfony has built-in decoders for XML and JSON, and as of 3.2, it adds encoders for YAML and CSV. It's also really easy to create your own encoders and decoders. In this case, what you want to do is implement the encoder and decoder interfaces. These are both pretty simple. For the encoder interface, all you need to do is implement this supports encoding method. This tells what format your encoder can handle. And then you implement the encode method to handle actually encoding the data. Likewise, for decoding, you implement the support decoding method, saying what format you can decode, and then a decode method to actually handle the decoding of your data. You can also create your own normalizer. This is handy for, say, you're importing an array or a person object or something, and the keys in that array or the fields in that object don't match, say, especially if you're going to XML and you have an XSD that you have to conform to. Creating your own normalizer, in this case, is a really good thing because that gives you an opportunity to get everything into the format that the XSD is going to expect. Once you've got all this, then you can tell the serializer to use your own normalizer and your own encoder, just the way Symfony does its own built-ins. If you want to learn more about serializer and how that works and adding your own formats, the Drupal HAL module is a really good one for that. So I highly recommend looking into that one to learn more about that stuff. That leaves us with one more to look at. This is probably my favorite of all the ones that I've come across on this little journey of mine here. It's the Symfony Validator component. So say we have this variable. We don't know where it came from, what value might be in it. We know, though, that it can't be a null. It's got to be a string. It's got to be between 15 and 255 characters long, and it has to be a valid email address. So PHP, it's not too bad to go ahead and set up these checks here like we see there. And if everything passes, we go ahead and do stuff, no problem. But what if something goes wrong in there? We got to tell the user something. We can't just say, hey, this didn't work. They're going to want to know, was it not a string? Was it null? Was it too long? Was it not an email? And now all of a sudden you're down into your else block here, and with the different permutations that we've got up here, that can get pretty ugly. And then even once you've got that implemented and you only want to do that once, you want to use it elsewhere, you could put it into a class and make that useful for other people, but it's still pretty ugly. So that's why you want to be using Validator. So to use a validator, or to get a validator, you just include the Validator validation class. This gives you two methods. The first one is create validator. This just creates a standard validator. You can get a little fancier and use create validator builder and create a configurable validator. I haven't looked at that one at all, so I'm only going to tell you that it exists, and the rest of my examples are going to use create validator, which we do here. So now we have a validator. It's not going to validate anything. And for that, Symfony provides constraints. So we'll add some constraints for our validator. We wanted to make sure that our string wasn't null, that it was a string type, that it was of a certain length, and that it was an email. Symfony provides all of these for us, so we use these in our code. And then we can go and validate. So I've got this string that came in here. Somebody was entering this malicious thing into our email field. We want to make sure that doesn't get through. So we call validate. Then we just pass constructors for the different constraint methods along to the validate method, excuse me. If any of these don't pass, they will throw violations. And so we check after we're done. We check to see if we've got any violations. If we've got violations, we can report them, do something, throw exceptions. That's probably what I would do in that case. But that's how those work. The constraints each provide their own messages also. So you don't have to even worry about coming up with a message for anything. Symfony provides all of these as built-ins. If those aren't enough, you can create your own. Drupal, I believe, actually creates a couple of its own too. I didn't do a good job on bringing those into here, for which I apologize. But if you want to make one of your own, you extend the Validator Constraint class. Now you notice that in Drupal, validators are plugins. So they have to be in Drupal, my module name, plugin validation constraint directory. That if you've got to put them in there so that Drupal can find them. Once you've got that, it makes them really easy to use later on, as we'll see. In this one here, what I'm going to do is just make sure that an incoming name is my DO name, so that I can get all the credit for whatever is happening. So we see here, all I do is I give a message saying that it's not my DO name. A constraint also needs a validator. That's what this validated by method is down here. If you want to specify the class that's going to validate your constraint, you can specify it here. By default, Symfony is going to look for a validator that's the name of your constraint with validator on the end, and that's what I've done here. So you extend the constraint validator class and then provide a validate method that has the logic that checks the value that's coming in. If it doesn't pass that logic, then it adds a violation that you can catch later on, and then it will display the message that we saw earlier in the constraint. You can also do constraints on entire entities. In this case, you just pass an entity in instead of a single value, and then inside of the validate method, you can use all of the entity functions to check things against theirs. So in this one, I've got an entity name called wasName. I want to have a constraint called good wasName to make sure that any wasName that I create is valid. A wasName, for our purposes, has to have at least one dongle and an equal number of cogs and sprockets. So I've got that in here. We've got just entity get dongles, entity get cogs, entity get sprockets, checks the values here. Notice also that when you build your violation, you can add a message at this point too. So if this fails, we will get exactly what's going on. So if a user tries to create a dongle or a wasName with no dongles, 9 sprockets and 10 cogs, they're going to get a message back saying that it has no dongles and that there's a problem with cogs and sprockets. So once you've got your constraints set up, you can use it just like any of Symfony's own. And in Drupal, remember when we looked at it earlier, we had to call a validate method and pass the constraints to that. In Drupal, it's even easier because we've got them registered as plugins. We can now add them however we want. So the base field definition provides add constraint and set constraints methods. This lets you add constraints to any field definition. So now say we have our email, like we talked about earlier. We want to make sure that it's not null. We want to make sure that it's a string between 15 and 255 characters, and that it's a valid email. And this will take care of us for us. To add constraints to an entity, you just include a constraint attribute in your entity notation. And you can add as many constraints in there. So here we see my wasName, and I want to make sure that it's a good wasName. This is really, really big, actually. Up until Drupal 7, form validation basically happened inside a validate form method. And the form would actually implement all of the logic to to validate whatever was coming in. So as of Drupal 8, with this stuff, validation belongs to entities. You define an entity, you define your constraints, and so entities can validate themselves rather than relying on some other code to validate them. This is great because we can validate anytime. We don't have to be inside of a form. So if we're, as earlier we saw, we're taking an XML data, converting it to objects. If our objects can validate themselves, if we get some bad XML in, we can check that there. It makes it easy to add things inside of tests, and just a lot easier. I'll just say that. If you look at the content entity form, what you'll see is that the validate form inside of Drupal's content entity form actually just calls entity validate and lets the entity take care of itself. And that's a really beautiful thing to end on, because I think everybody needs a little validation now and then. So again, this has just been some surface scratching. There's way too much of this to fit into 40 minutes or so. So there's plenty of reading for you to do. If nothing else along the way here, I hope I've at least piqued some curiosity, and that you'll start looking into using some of this Symfony goodness in your own code sometime soon. Maybe somebody will get interested enough to look into a component and give us a really deep dive next year. If you're interested in learning more about these, Drupal wraps a few of the components and adds a few of its own, and those are in the corelib Drupal component directory. I always wondered why there was corelib Drupal component, and now I know. In addition, the Symfony docs are really excellent at symfony.com. The API docs are also really excellent. They're full of details, easy to read. I actually lifted a whole lot of stuff from the Symfony docs for this presentation here today. So I urge you to check those out. They're really very good. As a parting gift, I will leave you this one more code snippet. You can add this to your settings.localphp file, and you'll get some more interesting debug output. I've even found adding this after the fact on some code that it's caught errors for me that Drupal's error, that Drupal stuff doesn't catch. So what is Drupal Haydn? If it's a little less than it was an hour ago, then mischief managed. Thank you all for being here today.